Perfect.
Hi, everyone. We're doing our midterm presentation for CIT260. Our group consists of Tiffany, Eureka, and I'm Mike. We'd just like to talk a little bit about what we've learned this semester. We've gone through different data types, creating methods and functions, the if, else if, and else statements. We've talked about scope and lifespan, the switching cases, and also the loops, for and while loops, as well as testing functions.
So the first thing we're going to go over is we're going to talk a little bit about our selection statements. And selection statements are used when you want something to have a certain action take place. And the first one, there's 4 of them. The first one I'm going to talk about is if statements. And these are used when you only have one true action. If it's false, it completely ignores that section of codes and skips to the next statement. So in this example that we used, if the player input length is less than 1, then it will say that it's an invalid request. But if it's not, then it ignores the statement completely as though it's not even there. So that's if statements.
So the second type of selection statements and if statements is the if-else statement, and this is used when there is a true action or a false action that we want to do, that we want to validate in the in our code. In this case, we're testing for the length of the file name. So in the statement if file name dot length less or equals to 1, we're testing if the valid file length which is 2 is valid in this piece of code. If it is valid, or if it is less than 2 characters, then we will show an error message, and we will say that the file name must be at least 2 characters. If it is valid and it is 2 characters or more, then we will, in the else statement, we will show a success message, and that's how an if-else statement is used. In the first case would be true, the file name is less than 2, and in the second, in the else, it would be false. The file name is greater than equal or greater than 2, so we can go ahead and proceed with the rest of the code.
Okay, and then the last selection type is the if, else ladder statement, and this is when you have more than 2 options. And the example we have here is when, as a function for selecting the difficulty of our game, when selecting between easy, medium, and hard. So if the user selects an E, they will get the easy mode, an M for medium, and then an H for hard. And then if they don't select any of those, it goes to the else statement, the last one, prompting them that they've entered an invalid entry and to try again. So these are good for more than 2 options, and you can have as many else if statements as you need to.
Perfect. And then switch statements are for when you want to check to see if a value is equal to one of the items that you have in your list. We've used these a whole lot in our game for menus. And so in this case, they would, if they specifically put in N, G, H, E, or X, it will take them to specific things. And then it also provides a spot for the default to be used as well if they had any other selection at all. So the case determines exactly what the valid value is, and then it will take them to that position, and that's the last of the selection statements.
Next, we go into the Java repetition statements. There are several types known, which are the for, statement while, and do while. In the case of the for, which we haven't used in our code yet, it allows us to repeat a set of statements for a set number of times. The second option, the second type of repetition statements, the while, allows us to validate up front if we want to go into the while loop or not. So in the example that we have here in the get input function, we have a while not valid, which is testing that if the value of the variable valid is true, it will stay. If it is false, it will stay within the loop and will execute everything that is within the loop. If it becomes true, then it will exit the loop or will not even enter the loop, and those statements will not be executed. The second type that we have, the third type actually that we have, the do while, allows us to go into the loop at least once. So if we have a set of tasks that we want to execute at least once, we use the do while. The test to validate the condition for the execution of the loop is done at the end. In this case that we have in the display menu function, we execute the statements once, it displays the menu, and then as the user presses the options in the menu, it will continually test if the option for letter E, or in this case exit the menu, has been pressed. If it has, then it will come out of the loop.
Okay, the next part is for testing any kind of function you have. The example we have here is from our game. It's called Calculate the Length of the Rope. And there's three inputs that it gets: the girth of the victim, the floor number that the user is on, and then the height of each floor. And then the output gives you the total amount of rope that you need. So we start with the validation rules, and it talks about how the girth must be between 20 and 40, the floor must be between 2 and 5, and then the height must be greater than 0 and less than 10. So the test matrix is to make sure that those rules in fact work. So you see with the first test, you have valid entries and you get a result. On tests 2 through 7, the return is -1, meaning that it failed and that it's somewhere it fell outside those boundaries. And then the last two, test 8 and 9, are the boundaries, and those allow for the extremes on both ends to make sure that it's working properly, the extremes of the inputs. At the bottom we have some pseudocode just explaining how it's supposed to work, and this is just like a mock draft so that we're able to write the code later on.
And then here it is, we're implementing that code. We changed the code from pseudocode to actual code. What we had to do was we had to determine where it could be used. That's why it's public. And then double is the type of value it's going to return. Calc length of rope is the name. And then you can see what it's calling for. It's calling for the girth, the floor, and the height. And they're all double. And so inside it, the first three statements tell basically where the girth, the floor, and the height, the ranges that they have to be in. And if they're outside of those ranges, it will return the -1 or the error statement. And then once all of those get satisfied, when you get down to it, you get down to the calculations. The knot is the girth divided by 12 because it's going from inches to feet, and then to determine how big the rope has to be, you take the knot and you add what floor you're on times by the height, because each floor is, say, 7 feet. And then you return, the function will return the variable rope length. And then that's how we used the test matrix to write the pseudocode and then changed from the pseudocode to the actual code to make it function.
Okay, and so in the way we test the function, and we put the matrix that we put together for the unit test matrix with all the cases, with all the expected values, and now we test for those. It's by using unit test functions or using JUnit within NetBeans to perform those tests. In the case that was explained, the calc length of rope function, we created within NetBeans a unit test function called test calc length of rope that implements all those test cases that we defined in the matrix. in the first example, the test case 1, we define the values for girth, for floor, for height, and then we define also a variable for the expected result. So based on the first scenario, the happy path scenario, we define that we executed it and we calculated that the result would be 22.8333. Then we instantiate the actual class where that function is. We implement a variable called result that it's going to have the result of executing the calc length of rope function. And then we use what it's called within JUnit assertions or test assertions, in this case the equals assertion, where we pass the expected result that we defined earlier, the result of the execution of the function, and we also define a margin of error that it's allowable for the result. So it will be the difference between the expected result and the result. Now, the assertion is executed, and then NetBeans has the functionality to interpret if the value, if the test was successful, so everything matched and everything is as expected, or if it didn't match, it will also determine that it was the test failed, and it will show that in the NetBeans IDE, the end result of those of the unit test. And that's how we used the unit test function. And it is a best practice to execute these tests for any code that we have that will return a result that can be determined and can be defined in test cases.
Next, we have the scope and the lifespan of variables. Scope, it talks about the boundaries within where the variable is able to work or be called, and it's confined to the block variable that it was defined in, and then lifespan goes with that, and that dictates when a variable is active in memory and can be used, and its life begins when it is called and ends at the end of the block. And Tiffany has an example of how that actually works.
All right.
Program.
So here it is in the example that we've been using. I'm going to start inward and work my way outward. So we're going to look at the not variable in the calc length of rope function. Because of where it is, its lifespan starts when you reach that line of code, and it ends when you finish out that block of code. So when you leave that function, its scope is within that function itself. So that not cannot be used inside the calc force needed down below, because that's in a different block of code. It's in a different function. But if you look up at the top inside the actor control class, that girth equals 24, that's within the whole scope. That whole scope can be inside the calc length of rope or the calc force needed, because it's the outermost block. So you kind of can work your way out to see what the scope of each of these variables are. Lifespan is really simple. Whichever block it's in, it is finished at the end of that block. So the not variable is finished when the calc length of rope function is finished performing. The force of friction down below is finished. Its lifespan ends when the calc force needed function is finished. And the girth, because it's in the outermost block, its lifespan doesn't end until you're completely finished with the actor control section. So that's how the scope and the lifespan works, and you can kind of see it with those images.
Okay, so and next we'll talk about passing by value and reference. So when we have a function, we pass values within the function. So the function can do something with those values that it received. In this case, receives variables. Java handles different types of variables differently when we pass them within a function. So in the simplest case, in the primitives case, which are the simplest types in Java, for example, double, an integer. In the examples that we use here, the girth, floor, and height, which are simple variables, they have a simple type. The actual value that is stored in the variable is passed to within the function, and then the function takes care of it and deals with it in the way it's processed. Now, when we're dealing with objects, it's different. Objects such as a string or a custom object, such as a player variable, for example, the way Java handles these objects is by passing the address of the object in memory to within the function, so that when the actual code that calls that variable is needed, Java will go to that address, picks up the value, and then does whatever it needs to do and process it, as in the example of the create player, where we're passing a string object called player's name, and in this case, but in this specific case, Java would get the memory address for the string object, get those values, and then process them. And that's how Java handles primitives and custom objects or objects differently, as these values are handled within functions. This is everything that we've covered so far in this semester in the CIT260 class, and that's pretty much it. That's a wrap up.